This is the third section of the statistical distributions chapter, and this is on cumulative probabilities. Now, we've done some problems where, for example, we needed to work out, let's say, the probability that x could be anything up to 2. And the way that we worked it out, we worked out the probability of 1, probability of 2, 0, 1, and then probability of 2. We added those together. Okay, if we had a question that was the probability that x was less than 4, then that would be the probability of 0, 1, 2, and 3 added together. If I had a question that said the probability that x was greater than or equal to 5, what I'd do is I'd do 1 minus the probability of all the ones on the other side that I haven't used, which is all the ones less than 4. Now, that can be a lot of work, working out these cumulative probabilities. I mean, what if we had a question where it was a binomial distribution and we had, let's say, 45 here and a probability of 4.2, and I needed to work out the probability of up to 40. Yeah, do we really want to do probability of 0 plus 1 plus ... all the way up to 40? That would take a long time to do. So to help us out, we've got our calculators and we've got tables. And what I've got here is a bit of a table. And these are cumulative tables. So what these tables give you, and it's in the formula book and it's in the back of the book, this gives you the probability up to a value of x. So basically it gives you the probability of 0 plus 1 plus ... all the way up to x. So how do we use this table? Well, let's look, for example, here. Okay, you can see it's P here. So this is the column where it's a binomial distribution and the probability is going to be 0.15. So that will go there. Okay, and what's the value of n? Well, the value of n, this whole block of values here, yeah, is for when n is 5. So I will put 5 here. Okay, so this is basically what this column tells us. Now, if I looked at this first value there, that gives us, let's put 5 in there, that first value is the probability that x is less than or equal to 0, which actually is the same as the probability of 0. So it's 0.4437. The next value down here, that gives us the probability up to 1, because you can see the 1 here. Yeah. So the probability up to the value of 1, which is basically the probability of 0 and 1 added together, that's 0.8352. Next row down, different color. So this gives us the probability of x less than or equal to 2, which would be 0.9734. Next one down in blue, that's the probability of x less than or equal to 3. Okay, so what's this? This is giving us these cumulative probabilities. So this is a quick way of finding the probabilities up to a value of x. Now, what if I didn't want the value of up to x? What if I wanted the values below x? So for example, what if I wanted to know the probability that x is less than 4? Well, what I need to do, I need to convert it into this type of probability. It needs to be written in this form because that's how the tables work. So the probability less than 4, you could think of as another way of thinking of this, it means fewer than 4. Okay, fewer than 4. Then the way that we would work that out is we would change it to the probability of x less than or equal to 3. Okay, think of it like whole numbers. If I was saying, right, I want the whole numbers, fewer than 4, what's the last whole number I get to? It would be 3. So when we change it to this, then we can use the table. Okay, what if I had a question that says, instead of less than, what if I wanted to know what was the probability that x was greater than or equal to 7. So again, we need to change it into a less than or equal to probability, a cumulative probability from 0. And the way that we do that, if I'm saying, right, I want the numbers, if we think of like whole numbers again, if I want the whole numbers greater than or equal to 7, that's like saying, well, I want 1 minus the probability of all the numbers up to 6. It's almost like the other half. Sometimes a number line helps. So if I was to draw this on a number line, and I've got 0 here, and then I've got, let's say, 6, 7 there, and this probability here, if I represent that on a number line, okay, that's this. Yeah. Now all the probabilities up to n add up to 1. So the probabilities from 0 up to wherever n is on our number line, so let's make our number line longer, all the way up to where n is, these probabilities in here, from there to there, they add up to 1. And I want to find the probability of greater than 7. Let's extend the arrow a bit then. So greater than 7, greater than or equal to 7. So that's going to be a line that goes all the way up to here, up to whatever n is. That might be 10, 20, 25, 27. So if I want to know those probabilities, wouldn't I actually be able to do these ones and do 1 minus that? Yeah. So that's how we get this 1 minus the probability that x is less than or equal to 6. If you think of a number line like this might help. We'll do maybe a couple more. So we've done greater than. What if it was, sorry, no, we've just done greater than or equal to. What if it was just greater than? What if it was, I need to find a probability that x is greater than 5. Well, the first thing we need to do is to say, well, if it's greater than 5, what's that using this inequality sign? Because we want to do that first. So greater than 5 actually means, if we're talking about whole numbers, greater than 5 actually means greater than or equal to 6. And then if this becomes a bit like the last one, this will be the probability of 1 minus x. So if I'm taking all the numbers greater than 6, then the other numbers that I've forgotten about are the numbers less than or equal to 5. And notice actually on this one that this value and this number are the same. That might be helpful if we want to do a shortcut. Now there's this table here, and this table sort of summarizes the phrases that we might see. The second column summarizes, well, what it actually means as a inequality, and the last column actually just summarizes what actual calculation that we do. Now you don't need to memorize this table, but be careful when you're working out these greater than or equal to probabilities. Take each question at a time, think of what it means. If it helps, draw a number line and use that to help you work out the probability that you want. Right, so on this question here, we can use either tables or we can use our calculators. I'm going to be using a calculator for this. Now, to use my calculator on this, I need to go to menu and 7. So I'll just write that here. So you press the menu button, which is next to the on button. Then we're going to do number 7. You'll see like it's a little picture of like a graph thing, a distribution. So menu and 7. Once we've done that, we actually need to press the down button because we need to access more of the menu. And we want binomial CD. CD just stands for cumulative, and C stands for cumulative. So once we've done page down number 1 and binomial CD. So we use binomial CD when we want to work out probabilities like this. If we want to work out probabilities where it says equal to a number, we use binomial PD. So you wouldn't press the down button, you would just choose number 4. So after you've done menu and 7, you then choose number 4. Right, let's have a look at these questions. So the first one, the probability that x is less than or equal to 7, that's not a problem. We can either look that up straight into the table or on our calculator. Now we go to variable number 2. We don't want a list, we just want a single value. My value of x is going to be 7, n is going to be 20, and p 0.4. Okay, so on your calculator, it's going to say binomial CD at the top, and then it will say x, then n, and then p, and you type in the value x 7, n 20, p 0.4, and if we do that, we get an answer, and we're going to write these answers to 4 decimal places. 0.415, it goes 89, so 4159 for part A. Okay, part B, this is asking for the probability of x less than 6. So step number 1, convert it to a less than or equal to. So if it's less than 6, the last whole number I'm going to is 5. So when I'm on my calculator and I've got binomial CD at the top, x is going to be 5 that I type in, n is still 20, and p 0.4. Now if we just press AC to clear, all we need to change is x. Yeah, the 20 and the 0.4 already there, so we just press equal a couple of times, and then what we'll get is 0.125 and round it to 6. So again, 4 decimal places. And then C, if it's asking for the probability that x is greater than 15, well, think about what numbers we're leaving out. If it's all the numbers greater than or equal to 15, it's going to be 1 minus the probability of the numbers less than or equal to 14. Now again, if you want to draw a number line to help you, you can. So this is a number line of whole numbers. So I've got 0 here. Let's just do like 14, 15, 16. Now this number line goes up to 20 because n is 20. And this question is saying, work out the probability of this greater than or equal to 15 up to here. Okay, we know that all of these probabilities here add up to 1. Now, if we want to work out that probability, actually, what we can do is work out this one. Yeah, so there you can easily see that, okay, if I want to work out the probability that x is greater than or equal to 15, then actually it's going to be 1 minus the probability of x less than or equal to 14. So if you really get stuck, use a number line to help you. Now, let's go to binomial CD again. X this time is going to be 14. N and P are unchanged at 20 and 0.4. So what I'm going to do is press AC. I only need to change X to 14. Okay, and then I get a number come up. Okay, this is not my final answer because I need to do 1 minus that. And that number, or actually the calculation is going to be 1 minus this 0.9983 ... Now what I would do is press menu now and go to number 1, change it back to a calculator. So menu and 1, and now do 1 minus answer. So even though you're doing 1 minus answer, still write down 1 minus that decimal. You can round it to 4 decimal places or just put ... to show that it carries on. So by doing 1 minus answer, I get like the exact answer, and that's going to be 0. There's 2 zeros, and then 16. Now, if you get a number that comes up in standard form, you want to change it to decimal, press, so let me show you how to do this. So standard form answer. So you get an answer in standard form. What do we do? If you do shift and ENG, and I think you need to do that twice, it will change it, basically say 10 to the power of 0 at the end. Okay, it will change your answer, or basically what it does is it changes between 10 to the power 0, 10 to the power 3, 10 to the power 6, 10 to the power 9, or 10 to the power -3, -9, the types of powers that engineers are interested in. So, you know, I got an answer which was in standard form. So I got 1.61152 times 10 to the -3. That's not particularly useful in terms of rounding it to 4 decimal places, and I don't want to really spend precious time converting that standard form number to a decimal, so I get a calculator to do it. So I did shift and ENG button. I think I did that twice. The ENG button, that's next to the bracket, next to this bracket here. And if you do that, it will do the hard work for you, and it's really handy, like just changing things back to 10 to the power 0, which is how we would normally expect to see it. So on this example here, spinner is designed so the probability it lands on red is 0.3. Jane has 12 spins. Find the probability that Jane obtains in part A no more than 12 reds. Okay, so no more than, sorry, not 12 reds, 2 reds. No more than 2 reds. Well, first of all, let's write down this. It's a binomial problem. There are 12 spins, so that's our n. The probability of success is 0.3, and we want to work out the probability there are no more than 2 reds. Okay, it means the most you can go up to is 2. Now I've got the table here, so we could actually, rather than use our calculator, we can just read off the values from this column. So less than or equal to 2, I can see it here, 0.2528. Yeah, you can also get that from your calculator. So that's the value that we use for part A. So 0.2528. Okay, part B, still the same binomial distribution with 12 spins and the probability of success being 0.3. This time it says at least 5 reds. At least 5 means 5 or more. If someone said to go on this fairground ride you need to be at least 10 years old, that means you can be 10 years old or older. So if it helps, you can think of these values as being like ages. Sometimes that might help. Now we can't work that out directly. We need to do 1 minus the probability that x is less than or equal to 4. Again, you could use a number line to help you. I've just drawn one here. So we're going from no successes up to 20. And we want to work out the probability that we get more than 5 successes. So basically we want to work out this. We can work out this from 0 to 4 there, and then we can just do, since these probabilities from there to there add up to 1, we can do 1 minus the probability up to or equal to 4. So if a number line helps you, you can. Now I can do 1 minus. Now I can look this value up in the table. Less than or equal to 4 is here, so it's 0.7237. So 0.7237. I've got to take that away from 1. Let's do that. 1 minus 0.7237, and that is 0.2763. 0.2763. Again, like part A, we could work this out on a calculator. Now, if you were working it out on a calculator, once you've worked out the probability, press menu and 1 to go back to a calculator, and then do 1 minus answer, and that will give you the exact working. So once you've worked out the probability, press menu, press 1, so it turns back into a normal calculator, and then do 1 minus, and then press the answer button to get the exact figure. Right, now part C, it says that Jane decides to use this spinner for a class competition. She wants the probability of winning a prize to be less than 5%, basically. Each member of the class will have 12 spins. Okay, so it's still, n is still 12, and a number of reds will be recorded. How many reds? Find how many reds are needed to win a prize. Now, what does this mean? She wants the probability of the prize to be less than 0.05%. So it's almost like, right, what's the minimum number of reds she needs to for a person to win a prize? Okay, so what's the minimum number of reds? So X is the number of reds that's needed to win a prize, and that probability needs to be less than 0.5%. Oh, sorry, 0.05%. Now, what we're going to do here, we're going to write that probability of X greater than or equal to X like this: 1 minus the probability of X less than or equal to X minus 1. Now, when we've done previous problems, and these were numbers here and here, what you would have found is that this number is always 1 less than this. Yeah, so in the previous one, we had 5 here, and then a less than or equal to is 4, it's 1 less. If this was 10, this would be 9. So we're just using algebra here, and that needs to be less than 0.05. Now what I'm going to do next is I'm going to take away 1 from both sides, so I end up with negative probability X less than or equal to X minus 1 is less than negative 0.95. Now in the next step, I'm going to times both sides by negative 1. Now when I do that, we'll reverse the sign. Remember, with inequalities, if you times both sides by a negative number or divide both sides by a negative number, you reverse the sign. Okay, so I've now got this. So this is when I can now use the table. I'm looking for a value, which is going to be X minus 1, where the probability is greater than 0.95. So we've got the right part of the table highlighted. Let's go down the table until we get a probability greater than 0.95. So we go down, 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 down. Right. This is when I get a probability greater than 0.95. All of these were less than 0.95. So what does that tell me? Right, that's this value here, 6. So it's telling me that that bit in the red cloud, the x minus 1, is 6. So now we can say x minus 1 equals 6, which means that x equals 7. So what this means is that at least 7 reds are needed to win a prize. Okay, so at least 7 reds are needed to win a prize. Right, should now be able to do exercise 6C on pages 93 to 94, so it might be useful to recap things like this. So just going to make up some numbers. So if I have something like that, then we can go straight to the tables or our calculator. If I had something like this, then that would be 1 minus the probability x is less than or equal to 8. Then we can use our calculators for this bit here, or tables, and do 1 minus that. If I had the probability that x was less than 5, we change that to the probability that x is less than or equal to 4. And then again, we'd use our calculator. And the last type would be probability of x is greater than 10, which actually means the probability that x is greater than or equal to 11, which is 1 minus the probability x is less than or equal to 10. So a shortcut might be, with those types where it's greater than something, to go straight to this. And again, like the previous ones, we would now use our calculator on this part here. And when you give your answers, give probabilities to 4 decimal places. The reason we do that is because the tables are to 4 decimal places, and historically probability tables have been given to 4 decimal places.